water sport or his favorite water sport on a given day. On a given day. This is our problem statement. Okay. So we have 4 examples. Among them, 3 are positive examples, 1 is negative example. So what we are trying to do is, we are trying to find out a maximally specific hypothesis. Maximally specific hypothesis. So the purpose of our find S algorithm is to find maximally specific hypothesis. Just now I gave you example. What is a specific hypothesis and what is a general hypothesis? So we will start with the most specific hypothesis. What is the most specific hypothesis? Step number 1, start with, please correct yesterday's notes, start with most specific hypothesis. What is the most specific hypothesis? Tell me. Ashwini? What is the most specific hypothesis? Let us call it as 0. Most specific means it will not accept any values. Most general means it will accept any value. So most specific is, how many features are there? How many attributes are there? Sky, air temperature, humidity, wind, water, forecast. Totally 6 factors, 6 attributes. So pi, comma, 6 attributes. Second one pi, third one pi, fourth one pi, fifth one pi, sixth one pi. This is the most specific. It will not accept any values. And what we are trying to do now is, we are starting with the most specific, and based on the examples, we will move from specific to general in this find S algorithm. So now, let us modify our hypothesis by looking at the example 1. What is the example 1? What is the example 1? Tell me. What is the example 1?
Sky is sunny.
Yeah. Sky value is sunny. Let me change the color. Yeah. Okay. So, second example is sunny. Next, warm, normal, strong, warm, same. Warm, normal, warm, normal, strong, ఇంకోటి ఏంటి? నార్మల్, స్ట్రాంగ్, వార్మ్, సేమ్. And same. This is example 1. Now, based on this example, what we try to do is we try to modify our hypothesis. So, let us modify our hypothesis. What is our hypothesis now? H naught. So, let us try to form H1 based on example 1. Now, according to the first example, Aldo will enjoy the water sport if the sky is sunny. But our hypothesis is not accepting any values. So when you compare sunny and no value, which is more acceptable according to the data? Which is true? Sunny is true or pi is true? పిల్లలు, ఈ రెండిట్లో ఏది కరెక్ట్ హైపోథసిస్? సాయిశ్రీ, శైలజ, which is correct hypothesis? Pi or sunny? When he will enjoy the sport?
Sunny.
Sunny. That's what the example data says, sunny. So we will modify our hypothesis because pi is not accepting any values. I will write sunny, and when I compare warm and pi, warm is accepted because of the example. When I compare normal and pi, normal is accepted in hypothesis because example says when it is normal he will enjoy. And when I compare strong and pi, according to the example, strong is acceptable in hypothesis. Warm and pi, warm is more acceptable, and same. Okay. Let me write it here. Same. So this is H1. What we have done, we started with most specific hypothesis, and then we modified that based on what? Our given data. Now, let us go on to modify this with the next example. What is the next example? What is the next example? Tell me. What is the second example?
Sunny.
Sunny.
Warm.
Sunny, comma.
Warm.
Warm.
High.
Comma. High. Next.
Strong.
Strong.
Warm.
Warm.
Same.
Same, huh?
Yes, sir.
Okay, thank you. So now let us try to modify our hypothesis according to this example. What is our H1? Sunny. Let us form H2 now. Compare with H1. Sunny, sunny. So there is no problem. Both are saying sunny. So I will accept sunny. Next. Warm and warm. Both are same. So my hypothesis is correct. Here in the third instance, when I compare normal and high, there is a mismatch. That means,
High.
yeah, there is a mismatch. Because according to the first data, when humidity is normal, he is enjoying. According to the second example, when it is high, he is enjoying. That means Dharmarao likes chicken as well as mutton. So అలాంటప్పుడు నేను చికెన్ మటన్ అని చెప్పకూడదు, జనరల్ గా చెప్పాలి, నాన్ వెజ్ అని చెప్పాలి. So what I do in my hypothesis is I will say question mark. That means general, any value. It may be normal or high. Now compare strong and strong. Both are matching, so no problem. Warm and warm, no problem, same. So I have modified my hypothesis as per the example 2. What next? Example 3. Now in finders algorithm, this example 3 is a negative example. Is a negative example. It is no. So in finders algorithm, we will ignore the negative examples, or we omit negative examples. We will not consider them. So step number 5, fourth example. What is fourth example? Tell me please.
Sunny, warm.
Sunny, warm. Yes.
High.
High.
Strong, cool.
Strong. Yes.
Cool.
Cool.
Change.
Change. Now, according to this example 4, let us try to modify our H2. So when we omit our example H2, H3 is also equal to H2. We don't change any hypothesis. Now let us calculate H4, or let us propose H4. Now compare it with H3. Sunny, sunny. So absolutely no problem. My hypothesis is correct. Warm, warm. No problem. It is correct. And this is matching. Now question mark and high. Which I should consider? Question mark. More general. That is acceptable, because all positive examples should be considered. Next, strong and strong. Absolutely no problem. Matching. There it is warm. Ikkada. There it is warm. But now here it is warm. Here it is cool. So what should I say? Tell me.
Question mark, sir.
Question mark. Because it has to accept both values. There it is same. Here it is change. So what shall I say?
Question mark.
Question mark.
So this is our answer. What is this H4? H4 is a maximally specific hypothesis as per the finders algorithm. This is known as maximally specific hypothesis. Now, what are the limitations of finders algorithm? We know the procedure, simple procedure. We will start with most specific, that is all pies, and we will replace it with the first example. Then we will see all positive examples. Whenever there is any mismatch, if there is a match, we'll just write the same attribute. If there is a mismatch, we will put more generalized question mark. So that's how we'll proceed from most specific to maximally specific algorithm. But in that process, remember, we consider only positive examples. We don't consider negative examples. So obviously, there will be certain disadvantages with finders. What are the disadvantages? See, this is the procedure. I will send these slides to you later. You can just, we'll start with most specific, and if it is negative, we don't make any changes to the hypothesis. If the example is positive, then we will update our current hypothesis to to general condition to make it more generalized. We will repeat this. The same thing we have expressed in diagrammatic form. So this is the algorithm. Initialize h to the most specific for each positive instance x, for each attribute ai in small h. If ai is satisfied by x, that means match, do nothing. Otherwise, replace ai by next general, that means question mark. Output the hypothesis. So limitations. Number one, Findus algorithm, we are getting only one hypothesis. But is one hypothesis is sufficient to represent all the data is not known. See, you cannot explain all the data with a single statement. That is the problem. So we are outputting only one hypothesis. So we don't know whether there are many other consistent hypotheses as well. We are giving only one answer, but there may be more than one answer. Number two, Findus is output of Findus algorithm is most specific or maximally specific. But we are not sure whether we should go for maximally specific or maximally general. We are not very clear on that. Number three, what is number one? What is number one? Only one hypothesis is coming. We don't know whether it is sufficient or not. Number two, whether maximally specific or maximally general, which has to be considered, there is no clarity. Number three, sometimes the data may be containing some errors. Manaki ichina data lo there may be some errors. In that case, Findus algorithm leads to inconsistency. And there should be, in every algorithm, there should be facility to backtrack. See, we have come step by step to the forward. What is backtracking? Going back. But that facility is not there. These four are the disadvantages of Findus algorithm. Any doubts? Any doubts?